Alright, so I think I'm recording here. Now this time they want a little bit more information. Not only do they want the zeros of the function, but they want to know how the graph intersects the x-axis. Does it cross or does it do a touch and turn? So if we get it in factored form, that from there it'll be easy to answer that. Let's look and see, is this in standard form? Yeah, 7, 6, 5, 4, 3, 2. Is there a greatest common factor? Yes, x squared. So before I come in and try to find these factors of the constant term and leading coefficient, I need to rewrite this expression in standard form. So I'm going to give myself a little bit more room. I'm going to come in. Let's see, do I still have this open? What was that? Number 3. I'm asking you like you're here, like I'm expecting an answer. Going crazy. All right. I'm just going to copy this, and I think you'll see what I'm doing here in a second. So I need to rewrite f of x. X squared is the greatest common factor. Now, my polynomial of interest is going to be x to the 5th plus x to the 4th minus 2x cubed minus 2x squared plus 1. So when I fill out this portion, the factors of a naught and all of that, it's in reference to what I've written in pink here. My focus of interest is now on this polynomial. So this is kind of nice. Look at this. This constant term is 1. It has factors of plus or minus 1. The leading coefficient is 1. It has factors of 1. So the possible zeros are either 1 or negative 1. So that's kind of nice. Let's check and see if 1 is a possible zero of this function with synthetic division. Looks promising. Let's see. 1 comes down. 2 comes down. 0. 0. Negative 2. Well, I lied. It's not. I didn't have a 0. What about negative 1? Hey. I'm hoping. This 1 comes down. Negative 1. 0. 0. Negative 2. Positive 2. 0. 0. 1. Huh. A little bit surprised here. So if I haven't done anything wrong, let's see if, and I'll pause the video and I'll double check. This graph, this polynomial might cross the x-axis, but if it is, well, I know since it's a 5th degree, it's definitely crossing the x-axis at least once. But according to our answers, it's not a rational number. It's not crossing at 1 or negative 1. It might be crossing somewhere else. So let me pause this and check my work and stuff, and I'll come back and tell you if I... Alright, so I don't think I've done anything wrong in my arithmetic or in my algebra. Let's see if we can make some correct conclusions from this. So we tried to use the rational zero theorem to factor this, but it didn't work. Our list was pretty short, and at first that was like, oh, hey, wow, both of the either one of these or both of these are going to be x-intercepts and maybe even a repeated root, especially since they're asking us to talk about multiplicity and stuff. Well, it didn't turn out that way. We did not get a zero remainder. So I can factor this only so far to here, and this x to the 5th plus x to the 4th minus 2x cubed minus 2x squared. We'll talk about that in just here in a second. First, let's focus on this factor of x squared. Remember, if I set this expression equal to 0, then that means that either x squared equals 0 or this expression equals 0. So If x squared equals 0, then x equals 0. But this guy, x to the 5th plus x to the 4th minus 2x cubed minus 2x squared plus 1, I'm not sure if that would ever equal 0. At least not at first glance. So let's come back to that in just a second. Now, for right now, I have a 0 at x equals 0. The multiplicity of that is 2 because my exponent right here is 2. And since that's an even value, I know that the graph is intersecting the x-axis as a touch and turn. I'm going to abbreviate touch and turn with TNT. Now, that's as much information as I can get from this first factor. The second factor, remember, we're aware of that leading coefficient test. We're aware that this expression, this polynomial function, is of odd degree and a positive leading coefficient. Since the coefficient is positive, I know it's going up at the right, and since it's an odd factor, I know the end behavior is in opposite directions. I also know that properties of polynomial functions are smooth and continuous. I know that this point and this point, that is somehow these graphs are going to be connected. So in order, and I know there's no holes in the graph and there's no jumps, so I know that there's going to be, well, I know it's crossing. No, wait a minute. This one is not crossing at 0. Remember the original function f. I'm not talking about f. Let's call this p. P of x. It's what I've highlighted here. P of x is just a factor of that f of x. P of x, if it does cross the x-axis, which now we know that it does because I have to connect these 2 points somehow, but this is an irrational number. I know that this can't be a rational number because it would have been either 1 or negative 1. Now, what I don't know, with this being degree 5, it could come over, it could cross this, it could have 5 zeros, 5 x-intercepts, and they're all irrational numbers. So at this point, I really don't know. I know that there's at least one more 0. I can't tell you what it is other than it's an irrational number. I can't even tell you without looking at a graph, at a computer graph, if there's more than one x-intercept. But I know there's at least one. And without knowing more, it could do a touch and turn. It could be a repeated root because that 5 is big enough that it could be a squared. You know, if this were just a, well, if it was a line, we could figure out what it is. I don't know what the multiplicity is, so I don't know if it's going to be a touch and turn or a cross. I've pretty much filled this out as much as I can. Now, let's go and look at that Desmos graphing calculator and look at the graph and see if there's any contradictions to what we have here. Now remember, this is not the original function. This was the one that I was interested in, and I can see that it does have 3 zeros. But I can also see that look at that x-coordinate, that negative 1.618. I haven't yet figured out how to tell the calculator to round it to more than 3 decimals, but I believe that's an irrational number. Because remember, we were expecting 1 and negative 1 if it was rational. Look at this guy over here. This 0.618 is rounded to 3 decimals. I believe the true number goes on forever with no repeating pattern. It's an infinite decimal. Look at this x-intercept, 1.325, the same thing. So those were 3 of the 5, and neither one of these are repeated roots. So the other 2 roots, well, 3, 4. I think these are all 1 because look, it's crossing. If the exponent were 3, it'd be a lot flatter. It'd still cross, but it'd cross being flatter. I believe that there's 2 complex numbers that are also zeros of this function. And we don't have a method to find those other than to know that they kind of exist. Well, I know they exist. At your point in your tool bag, I don't think that I would not expect you to know that yet. Let's come in and look at what the original, I'll pause the video and key in the original function and look and see if it does a touch and turn at 0 like we expected. Well, rather than taking the time to type the whole thing in again, you can look over here and see what I did. I knew what it was in factored form. It was a lot faster for me to just type x squared. So this was the original f of x. This was the original function they gave me. So if I look at what we have here, this x-intercept, this negative 1.618, I believe that's an irrational number. Look at 0. Hey, we found x equals 0, and look, it's doing a touch and turn. Boy, I don't know how to turn that. Okay, click it again. So we were correct in saying that x equals 0 is an x-intercept. We were correct in our table with a multiplicity of 2 saying it does a touch and turn. Maybe you have to zoom in a little bit better to see that, yeah, see how it's coming down, touching and turning. Now, this intercept right here, this 0.618, I believe that's an irrational number. That's just been rounded to 3 decimals. Same over here. I believe that this 1.325, that's an irrational number that has just been rounded to 3 decimals. Because remember, in our list, said it would have been -1 or +1 as the x-intercept. So that's as far as we can go for that problem. And in a way, it's kind of a little bit of a typo because I don't believe that our intention was to give you that type of a problem and stuff, at least not quite yet. Sorry about that. But it wasn't a waste. We did learn quite a bit from it. Talk to you later. Bye.